Need help? Watch it. Okay, a pilot in an airplane observes the angle of depression to points A and B on opposite shores of the lake. Measures 32 and 45. We've got angles of depression again. That should tell you something, right? The plane is flying at an altitude of 9750, not directly over the lake. Determine the width of the lake. In this case, the way I'm gonna picture, like imagine this lake here, and there's the one end and the other end, and we're not directly over the lake. So either you make the pilot of the plane be up here or here, somewhere on either side, but not immediately above the lake. That's the idea here. So if we're going over here, this is the pilot. Maybe this is the front of the lake, this is the back of the lake. And remember, angles of depression, you have to introduce a horizontal. And so we're looking this way, and we're looking that way. This is important here, not directly over the lake. The question I did previously on page 50, I will say something about that one. It's not specific enough. Like, are we doing this here as well, where we're a ship here and we're looking at the front and the back, or are we like above it? So I will tell you on a test or quiz, like, are we above it, or is it like off on the distance, right? I'll give you some sort of hint. Like here, I give you a hint, right? You're not over the lake. So you got to be this way or that way. It doesn't matter to me. Now the other thing is, which one is 45, which one is 32? Well, the smallest angle is 32. And then the largest one goes from end to end. That one is, what I do is I do this. I kind of go on the line to let everyone know that it's the whole thing. Okay? All right. Let's flood this thing with angles. Flood it. Oh, there's one more thing that I'm missing. They tell me what the altitude is. The height of anything is always measured straight down to the ground, right? So you have to introduce that height here. So you kind of extend your triangle. You have a 90 there for sure, because this is the height. This is 9750. And I will also make a straight line going across that lake, because we're assuming that that's the case for our triangle. So let's flood it now. The 32 here, we follow that diagonal. This is 32. This is 45 all the way to this diagonal, which is a transversal technically. So if it's 45 there, the 45 goes here. This pen is dying. So we've got this 45 coming in here, alternate interior. The 32 comes in here. If this is 45, then I know that this is 135, because these add up to 180. Let's figure out this little bit here. This is 45 minus 32, so that would be 13, correct? So I filled it up with angles. Perhaps I could use this piece here yet as well. And let's see here. This is 55, right? If this is 45, then what's this going to be here? 45 also, right? Or you see this triangle, you go 180 minus 90 minus 45. This ends up being 45 here. Do you notice something? What are these two angles? 45. So look at this side, and across from it, you've got a 45. That means that this 45 will have the same length across from it. So this is 9750. If you didn't catch it, you will have done sine law, you will have realized, oh, I get the same answer. How come? Because it's an isosceles triangle. Isosceles triangle. Okay? Determine the width of the lake. So let's call this W. We want to know this. So pay attention to this part, okay? We want to somehow find this, okay? So we've got a few options here. My suggestion would be, since you have the altitude, you need to start with this one. I'm going to find a side that is shared between these two triangles, okay? And then I'm going to move into this triangle. So I'm going to start here, then move into this one. So let's see here. With this one, I'm going to call this X here. This is 90. This is 9750. This is 9750. This is 45, 45. My bad, it's a bit small. It doesn't matter which pair you want to use. We're just going to say sine of 45 over a 9750. Make sure you pay attention now, Jeremy, okay? Sine of 90 over x. Okay, so x is equal to 9750 times sine of 90 divided by sine of 45. So this is 9750 times 1, right? We don't need to do that part. Divided by sine of 45. So that's 13788.5822. To be honest, if you round to 2 decimals along the way, I'm not going to be too picky with that when it comes to these questions, but try to use as many decimals as possible. So this is important to me. Now I'm going to move into that second triangle. Let's sketch it out real quick. Where this is W, I know that this is 135. I know that this is 13. I know that this is 32. And we know that this is 13788.5822. I'm going to use a highlighter for this one. So this side is this one here. So if you can somehow find a side that is shared between the right triangle and the other one, go for it, right? It's this one right here. Do I have a pair in here? It's hard to see. It's really hard to see, I would say. But this angle is across that side. Okay. So you've got a pair. We're not using cosine law a whole lot. Have you noticed that? A lot of questions can be done using sine law more often than cosine law. Sine law is very obvious. Side, side, side. Or side, angle, side, right? So I'll give you more information to start. So this is my pair. So I'm going to go sine of 32 over 13788.5822. That is equal to, I have to use 13 to find W. So sine of 13 over W. We're also not solving for a whole lot of angles lately. We're solving for sides most of the time, so keep that in mind. don't forget how to do the rest. So we cross multiply here. And you get 5,853 and 26 meters. Okay. Direct distance from plane to point A. Where is point A? Oh, A and B. I call it F and B. We'll just leave that one. We'll just leave that one. Okay. Or what I'm going to say here is this. If what that question is asking you, we already found this. It's asking for that one. This one right here. You would do the exact same thing, except for instead of 13 to find W, you'd use 135 to find this. Okay? You'd use the same triangle.